Study guide for Chapter 4 test. A triangle that does not contain a right angle is called an oblique triangle. Solving such triangle means finding its sides and its angles. Complete the statement below for the law of sines. Here's our statement. This is our answer choice. Number 3, we can always use the law of sines to find missing parts in which one side and two angles are given. Number 4, ask you to solve the triangle. We're going to set this up. We're going to use the law of sines. We're going to use cross products. First thing we're going to do here is we're going to find the missing angle by just subtracting those two angles from 180. Then we'll find C and we'll find B similarly. Question 5 is also law of sines. Question 6. Question 6 says, two sides and an angle of a triangle are given. Determine whether the given measurements produce one triangle, two, or none. So they give you A, B, and angle A. So we use this to find angle B to be 24 degrees. Then to find angle C, we subtract those two known angles. Then we find angle C. So we have one possible angle. One possible triangle. And then we have number 6. Let's see. Number 7, similar question. Here's where I've worked out number 7 using the law of sines. Subtract from 180, use the law of sines. Number 8, we're going to use the formula for the area. Number 9, we're going to use that a triangle is 180 degrees. Or no, number 9's here. I was talking about number 10. I'll go ahead and talk about 10 and then go back to 9. Triangle's 180. Set that up. We'll find the distance because what we're looking for is from the base of the tower to the top of the tower. So we are looking for that distance right there. Question 9, here's our triangle. It's actually 3 triangles. So I've drawn it here. I'm going to start with this one. I'm going to start with this oblique triangle. And I'm going to find angle B by doing 180 minus 76. So that's going to give me 104. Then I can find angle C. So I know the angles. I use the law of sines to find the missing side A. Because A, this side right here, is important because it is the hypotenuse of this little right triangle. So then I switch over to this right triangle. I set up the law of sines. No, not the law of sines. The fact that the sine is the opposite over the hypotenuse. And I solve to find H. 11. If A, B, and C are the measures of any triangle, and A, B, and C are the lengths of the sides opposite to the corresponding angles, we want the law of cosines. So there's my law of cosines. To solve an oblique triangle, given two sides and an included side. Pardon me, I yawned. First step is to find the missing side using the law of cosines. Then use the law of sines to find the opposite angle opposite the shorter of the two sides. This angle is always acute. Third angle is found by subtracting from 180. Number 13 asks you about Heron's formula. So we have it here. And number 14. I want you to solve the triangle using the law of cosines. So we do that. 15, same thing. Here's 15. I want you to be careful when you're solving using the law of cosines. When they tell you not to round to the end, they don't want you to put this in the calculator and get 1.4. They want you to actually use this in your law of sines. Okay? If you don't, you're going to get 38.4 instead of 38.9. So it's just going to be off by a smidgen, but it's going to change your rounding. So that's what they mean on this section. That was 15. Let's see, what's the next one I want to cover with y'all? 18, using Heron's formula. You're going to need to do, if they give you A, B, and C, first do S, and plug in. That's pretty self-sufficient. Let's see, 19. Plug in, use the law of cosines. 20 starts at our vector problem. A vector is a quantity with both magnitude and direction. The vectors that appear to be equal here are B and B. Consider the following. The horizontal component of V is A, and the vertical component is B. The magnitude is the square root of A squared plus B squared. If this vector is AB, an algebraic vector whose initial point is at the origin, then the vector is called a position vector. Fill in the blanks here. It's pretty self-explanatory. If you're adding the vectors, you add their horizontal components and the vertical components. If you're subtracting, then you subtract. If you're multiplying by a scalar, then you just multiply. Sketching the vector, horizontal is 3, vertical is 3, so it's vector C. Magnitude would be square root of 3 squared plus 3 squared, square root of 18, which is 2 times 9, so we get 3 square roots of 2. 26, we're going to add the, we'll get the positions. These are not vectors, these are positions, so we need to use this formula. You're adding on 27, you're subtracting on 28. And on 29, you need to multiply first.
I'm sure you.
So multiply first by the 3, and then put in the formula.